All right, hey, today we're going to talk about completing the square. Now, I'll just be honest, it does take a little bit longer, so this might be a longer video than what you're used to seeing. First one's not too bad. Second one, we're going to kind of combine a lot of skills into one. So let's take a look. Completing the square. What we're trying to do is we're trying to break this down. This is not factorable right now. So we're trying to force it to be factorable. And how we do that is making it a perfect square. Meaning, like if I had x minus 4 times x minus 4. I have x minus 4 squared, right? It's the same thing times itself. So that's what we're going to try to do. What we need to do first is move our c term to the other side of our equation. So I'm going to say x squared plus 6x. I'm going to move this by adding 2. So opposite of subtracting 2 would be add 2 to both sides. I need to leave a space. So make sure you leave a space where c was. And then you're going to move that c to the other side. So when you move from one side of the equation to the other, you have to do the opposite function. So we're going to add 2 to both sides. Now we need to set up our parentheses. We need to take half of our b term. That's just going to be something you have to memorize. So half of b is 6, so half of that is 3. So x plus 3. Now if this were negative, like x squared minus 6x, then this would be x minus 3. So you're going to take half and it's going to keep the sign. Now this square right here is my reminder that, oh, I need to complete the square. I need to multiply or square 3. So 3 squared, or 3 times 3, is 9. And so it's always going to be positive. But I can't just add a random 9 in there. So whatever I do to one side, I have to do to the other. So if I add 9 to the left side of my equal sign, I need to add 9 to the right side of my equal sign. And so I know that this seems kind of confusing. It's kind of a couple steps in one. But to complete the square, we need to take half of our b term. So half of a positive 6 is a positive 3. And then I need to square that. So 3 squared, or 3 times 3, is 9. Whatever I do to one side, I have to do to the other. Now I'm going to reduce or simplify 2 plus 9. Well, 2 plus 9 is 11. So what we did is we forced this to be a perfect square. Two numbers that multiply to 9 that add to 6 are 3 and 3, right? 3 times 3 is 9. 3 plus 3 is 6. So we manipulated and forced this to be a perfect square. So now it was factorable, and we got x plus 3 times x plus 3, or x plus 3 squared. However, why would we even do that? Who made this up? Some old Greek dude who definitely was not married. Feel me? The reason we did this, though, is because now we can solve by taking the square roots, which is what we just got done doing. So how do I undo a square? Well, I take the square root. So what I have left is this x plus 3. And this is equal to, if I take the square root, I need to use a plus or minus. And so this is plus or minus the square root of 11. Now the very last step that we have to do is get x by itself. So how do I do that? I'm going to subtract 3 from both sides. Now, when you subtract 3 from both sides, you want to make sure that whatever number you add or subtract needs to go in front of that plus or minus. So we get x equals this negative 3 plus or minus the square root of 11. Because we can't simplify the square root of 11, we're going to just leave it there. And those are 2 answers. We know it's 2 answers because we get one answer from negative 3 plus square root of 11, and the second from negative 3 minus square root of 11. 2 answers come from our highest exponent being a 2. All right, moving forward, number 2 is going to be a little more challenging. Notice how a was 1 here, a is not 1 over there, so of course class is over. And we have to do one more step. So let's go ahead and see. First step, move c to the other side. And so when I do that, I have 5x squared minus 30x. I'm going to leave my space, and this is equal to, well, to move c, I have to add 3 to both sides. So this becomes a positive 3. So I left that space, but I need to divide each term by 5. So I want to make sure that a is equal to 1. And just like in factoring, we want a to be 1. So we're going to divide each term by 5. And I'm left with x squared minus a 6x, leaving my space, and this is equal to, I'm going to write the fraction 3 over 5. Okay, now the completing the square part. Half of 6, so half of our b term, x minus 3. It's not always going to be 6, just kind of worked out that way. But because this was a minus 6, that has to be minus 3. This square is my reminder that I need to square that negative 3. Well, a negative times a negative is positive. So a negative 3 times negative 3 is positive 9. So this will always be positive. Whatever I do to one side, I have to do to the other. And again, what we're saying is, hey, what are 2 numbers that multiply to a positive 9 but add to a negative 6. Oh, negative 3 and negative 3, right? Negative times negative, positive. Negative 3 plus negative 3, negative 6. So we're forcing it to be a perfect square. And then this equals, now we have to combine these. So in your calculator, you could do parentheses, 3 divided by 5, parentheses, plus 9. And if you hit math, enter, enter, it'll find a common denominator and it'll reduce that fraction down for you. So you should get 48 over 5. Okay, so put that in your calculator, 3/5 plus 9, math, enter, enter, 48 over 5 is what you get. All right, to finish this off, we need to take the square root of both sides. So I get x minus 3 equals the square root of 48 over the square root of 5. So when we square root both sides, we get the top and bottom. Notice I forgot something. I forgot the plus or minus. As soon as you take the square root, don't forget your plus or minus. Now, I don't know what the square root of 5 is. That doesn't simplify anymore. But I do know that the square root of 48 reduces. So kind of move off to the side, and let's break down 48. So if I break down 48, two numbers, any two numbers that multiply to get you 48. So we get 6 times 8. You could have said 2 times 24. You could have said a bunch of things. Doesn't really matter. Any two numbers. So what times what gets me 6? Well, a 2 times a 3. Two numbers multiply to give me 8. A 2 times a 4. And then 2 times 2 gives me 4. Remember, we're only looking for prime numbers. Any number that can only be multiplied 1 in itself to get to that. So 2, 3, 2, 2, and 2. So if I did 2 times 3 times 2 times 2 times 2, I'd get back to 48. So I don't care. I'm ignoring the 4, I'm ignoring the 6, and I'm ignoring the 8. I don't care about those. That's why I circle the prime numbers. Those are the numbers I'm looking for. I'm looking for groups of 2, right? So I have 2 2's here. So there's one group, so I'm going to pull that 2 out. I have another group of 2 here, so I have 2 there. I'm going to pull another group of 2's out. I have no more groups, no more pairs that match. So where those numbers go that are left over is they go underneath the square root. So that 3 is by itself, so it stays home. Now, 2 times 2 is 4. So what we're saying is that the square root of 48 is 4 radical 3. You will get faster at that the more that we do it. So with that understanding, what we have now is we have x minus 3 equals the plus or minus. We know that the square root of 48, we just found, is 4 radical 3. And this is all over the square root of 5. Okay, the only thing we did from this step to this step was figure out square root of 48 is 4 radical 3. Now, we cannot have a square root in the bottom, in the denominator of our fraction. So how we undo that is by multiplying the top and bottom by the square root of 5 over the square root of 5. Remember, you can multiply by 1 without changing the fraction. Anything divided by itself is 1. So to undo or to get rid of the square root out of the denominator, you multiply top and bottom of your fraction by that very same denominator. And that'll get rid of that radical. Let's see what happens. So I still have x minus 3 equals plus or minus. When I multiply fractions, I multiply this straight across the top, straight across the bottom. When you multiply radicals, you're multiplying 4, because it's the number on the outside of the radical, with the 1 that's technically on the outside of that radical. 4 times 1 is 4. Then you need to multiply the square roots together. Square root of 3 times square root of 5 is the square root of 15. 3 times 5 is 15. They're both underneath the square root, so I'm going to multiply them together. Here's what happens here. Notice this. Square root of 5 times the square root of 5. That is the square root of 25. Well, what is the square root of 25? Well, the square root of 25 is 5. This is why we do this. Anytime you have a square root times itself, the square roots cancel out, or they reduce out, and you're left with whatever number is underneath there. So if I had the square root of 7 times the square root of 7, my answer would be 7. If I had the square root of 25 times the square root of 25, my answer would be 25. So anytime I have a square root times itself, that number is what is left over. Okay, one last step. We need to add this 3 to both sides. And remember, when we do that, we are placing this 3 in front of our plus or minus. So we get x equals this positive 3 plus or minus the 4 radical 15 over 5. Now, another common mistake is that people will say, oh, hey, hold on, 15 divided by 5, that's 3, right? You can't, you're right, but you cannot simplify or reduce a number that's under the radical with a number that is not under a radical. So you have to be careful here. So here are our two solutions. And again, man, the next time you go get your hair cut and they're like, wow, I have this problem, I can't factor it. And you're like, hey, it turns out I know how to complete the square, so don't worry about it. Like, you cut my hair, I'll complete the square, and we'll call it even. You know what I'm saying? Free haircut. So can't complain there.